Good morning, everyone, and welcome to today's webinar. My name is Brittany Castle, Marketing and Communications Manager for Air Force One. Our topic today is indoor air quality and workplace health and safety post-COVID-19. Before we get started, I would like to take a moment and go over a few housekeeping items. We want today's presentation to be extremely valuable for you, so we ask that you submit all questions by clicking the Q&A button on the right side of your screen, typing your question in the compose box, and selecting send. We will pause briefly between slides to address questions as they arise, and we'll also have 15 minutes following the presentation for additional Q&A. You can pause the webinar by clicking the button in the lower left corner of your screen. There are also other controls that will allow you to adjust the sound and video quality if needed. You will be able to watch a recording of this webinar by clicking the same link you used to join us today, and a PDF copy of the slide deck will be distributed to all attendees. As you know, over the past couple weeks, Governor Mike DeWine has offered guidance for his responsible Restart Ohio plan to reopen Ohio's economy in a phased-in approach. Although some unknowns remain, Air Force One is committed to providing the most accurate, up-to-date information regarding reopening facilities following the COVID-19 crisis. Today, I am joined by my team at Air Force One. You will be hearing from Brian Taylor, Director of Building Automation, and Austin Nutter, Building Automation Account Executive. Please refer to their bios by clicking the link on the right side of the screen now. Thank you both for being here today. Austin, I'll go ahead and turn it over to you.
Thanks, Brittany, and thanks everyone for joining the webinar today. We really appreciate it. We are respectful for your time, so we'll keep this to around 30 minutes with the potential of 15 minutes of Q&A afterwards. But I would recommend that if you do have questions, please ask them in line of the slides so we can respond with the proper context. So without any further ado, let's jump right in. Just a little backstory. This was kind of an organic presentation that kind of was developed with everybody facing the same troubles, and we were being asked by a lot of our clients and customers specifically how they should combat COVID-19 and improve indoor air quality in their workspace. So today's webinar will cover 4 topics: ventilation, system filters, maintaining air quality, and UVC photohydroionization, or PHI. So ventilation. Ventilation is essential to keeping your building safe and healthy. It has other benefits, including controlling building pressure and increasing the indoor air quality by diluting the polluted or stale indoor air. Economizes proportion relief and allows sufficient airflow to maintain healthy oxygen and CO2 levels.
Thanks, Austin. Do you care if I add a little bit to that?
Go ahead.
One of the things that we're finding, and being in the business, this is something that we see all the time, and that is whenever there's comfort issues, this is especially true on packaged equipment, where maybe it's not heating or cooling and you're in the off cycle and your unit's set for a minimum outdoor air. When it's really hot out, it kind of floods the space with hot, humid air, or when it's cool out, it floods the space with cool air. And then it constantly causes your equipment to cycle. This is not such an issue when it comes to air handling equipment that has chilled water and hot water, because you can temper the air proportionally. But because of that situation, a lot of people end up disconnecting their outdoor air dampers. Not only does this not bring in a lot of fresh air and help with IAQ in your space, but it also causes building pressure issues, which also have a myriad of other problems. Temperature control, any of your offices out near the walls or windows of the outer exterior of the building end up being cold because it ends up trying to pull air from every nook and cranny in the building. So as students go back, as people go back to work, it's very, very important to make sure that at a minimum, you're meeting your outdoor air for air change and for building pressure envelope control.
Thanks, Brian. I'll wait for one more slide, Brittany, before I see if we have any questions. So system filters, and systems filters is kind of what started this whole conversation. The CDC as well as DeWine's offices have been time and time again recommending high-rated filters, HEPA filters to combat this virus. But simply switching to high efficiency filters can be very dangerous. So we wanted to kind of combat that. And before any organization goes out and invests heavily in higher rated filters, we want to give them the kind of the full perspective of what that entails. You know, mechanical equipment is designed for specific filters and this pressure drop associated with each class. Higher rated filters could actually be a detriment by reducing the airflow and can cause significant damage. ASHRAE and I believe the CDC now both recommends changing HVAC systems filters, even if they do not appear dirty.
Yeah, and Austin, thank you. I'm going to add to that. There is the possibility of going up to maybe a MERV 13 when you have built-up air handlers that possibly have the horsepower, or they're on a VFD and they don't run at full capacity all the time. You can maintain airflow if you put in higher efficiency filters, but at the end of the day, putting in anything HEPA, I don't know, it's been probably 3 weeks back, maybe a month. Governor DeWine and had a specialist on that recommended going to HEPA filters on everybody's equipment. Most HEPA filters would basically reduce your airflow to zero. Now on a system that's hot water, chilled water, you wouldn't do any damage to the equipment, but you would get virtually no airflow. On packaged equipment where you have DX or gas heating, it would cause those things to operate on their limits and or not even run, or run and flood back and either burn out the heat exchanger and or cause significant damage to the DX cooling system. So just moving to a HEPA filter, there's a lot more things at play, and it's something that we have to discuss, and or whoever your service contractor or service provider is needs to make sure that the equipment that you're placing the filters in can handle the filters.
Thanks, Brian. That's something that I was about ready to say. Now, Brittany, do we have any questions that have come in yet?
None at this time.
All right, thank you. So maintaining air quality, and air quality plays a significant role in reducing harmful pathogens in a facility. Adding UVC or PHI is one of the only ways to properly disinfect air streams. UVC light alone will only mitigate the spread of bacteria, germs, fungi, and viruses that pass through the UV spectrum. And we're going to do a deeper dive in the coming slides in regards to UVC and PHI. So, as was stated in the previous slide, UVC and PHI reduce viruses, bacteria, odors, and pollutants. So how does that work? That's the question that the $10,000 question that everybody's asking. But essentially, it's creating advanced oxidation processes or friendly oxidizers. And what friendly oxidizers means is once the pathogen has been neutralized, whether on a hard surface or in the airspace, they'll revert to back to oxygen. UV light, or let me rewind. UV light has been used for decades in the medical industry as well as the food packaging industry to destroy germs, viruses, and bacteria. However, and this is the important factor, we're going to dive a little deeper into this, UV light is only effective in reducing the microorganisms that pass through the light rays. What we know with COVID-19 is that it's not an airborne virus, therefore it's likely to not pass any type of UVC application. PHI, on the other hand, can reduce microorganisms by 99.99% in the workspace and on all hard surfaces.
Yeah, Austin, I'd like to expand on that. When we talk about UV light, and Austin touched on that, it's been used for decades. It's been used a very long time. So specifically, UV has been used in equipment to disinfect the coil. So they were installed between the filter rack and your cooling coil. And the reason being is your cooling coil, whether DX or chilled water, is always wet because it's removing moisture from the air that it's bringing outdoors and in the space. So being wet and being relatively neutral temperature, it is a very, very, very mold, mildew, and other airborne pathogen friendly atmosphere to grow. And of course, anything that grows on your filters will ultimately, the spores and the bacteria themselves will go down into the airstream and make their way into your space. So UV light was concentrated on the coil face, which is has the most moisture, to make sure that any air that did pass through there, any spores were dead before they got to the wet, and anything that did end up trying to grow would be, and I don't want to call it killed, I want to call it deactivated, because it actually breaks down the cell at a molecular level, keeps it from being able to replicate, and effectively neutralizes it. So when we start talking about UVC and photohydroionization, PHI, let's just go there. My guys, I can't talk this morning. It uses UV light on a metal catalyst to create what Austin referred to as friendly oxidizer. So specifically, it creates O3, H2O2, and then OH, which exists in our atmosphere normally. They go into the space, they can neutralize the air in the space, hard surfaces, and then they also get returned back into the unit, and you get the same benefit of having UV on the coil, except it's coming back as an oxidizer. It also reduces smells and other things. So extremely effective in the healthcare, meat packing, and other food packaging types of businesses.
Brittany, have we had any questions come in?
Yes, we just got our first question in. The question is this a green solution?
You care if I answer, Austin?
Go ahead.
The short answer is yes. The long answer is it's a green solution in two ways. A, the oxidizers it create when it reacts with VOCs, airborne pathogens, and we'll just keep it at that because airborne pathogens is a myriad of things. It breaks down to oxygen. So it's basically creating an oxygen-rich environment. Now, when I say that, that doesn't mean you have, like somebody's pumping in oxygen and filling the whole space up. It keeps it at a very neutral condition. So because of this, you can reduce outside air down to the minimum just to maintain exhaust. And when I say maintain exhaust, it's the exhaust for your bathrooms, exhaust for kitchens, or exhaust for other things that has to run all the time. So we're only bringing in the amount of air to offset that and keep our space positive, and you're not having to add any more outside air. And when you combine this with demand CO2 ventilation, you only have to ventilate when the CO2 level gets high. And quite honestly, there's a couple, and we'll pass this documentation along. There's a couple of studies, specifically the DoD, where they did this on, I don't know, I think it's 50 buildings, and it reduced their HVAC, heating and cooling energy costs, and we'll call that electric and gas, by up to 40%. So that's significant. And it also qualifies for most energy conservation upgrades when you're looking at outside funding.
Thanks, Brian.
Austin, we got another question in.
Okay.
Can I use this in every room, every space, large or small? And the example they gave were arenas, etc.
Brian, do you want to jump in on that one, or do you want me to take it?
No, I can definitely fill in. Yes, you can use it in every room. What's great is if you have an air handler system that's attached to VAVs, let's just look at that as a traditional system. So you're installing this in a discharge site of your air handler that feeds X amount of VAVs based on however many rooms you have and however it's zoned out. So every connected load to that air handler would get the benefits of this. So you don't have to install it in every room. As long as your VAVs are maintaining their minimum airflow for air change at the VAV level, you will get enough of this to see the exact benefit.
And just briefly, this is something that we've been proposing for quite some time. We've scaled it between, you know, a 1-room, 500 square foot, you know, space to, you know, a 30 to 40,000 seat arena. So there are solutions that meet every application. It's just you need to take the CFM demands into effect so we don't undersize or oversize the technology or PHI.
I want to touch on the next question that we got, and that is this considered a clean room solution like hospitals? No, it is definitely not considered a clean room solution. There are many other items that go into that, not only air quality, but HEPA filtration down to a micron level that's well beyond equipment that would be installed in any general commercial or academic setting. So yeah, the answer is no. It's not a clean room solution. There would be other aspects to meet those criteria.
Okay, so jumping on to the next slide, we wanted to talk about some people have exposure to the various technologies that exist to kind of actively neutralize contaminants or pathogens. We spoke briefly about UVC, and UVC naturally is a shortwave germicidal wave that is actually fully absorbed by our ozone layer and atmosphere. Therefore, most UVC solutions are generating the same type of wavelength to replicate the germicidal effects of UVC light. Photohydroionization, or PHI, is what we've talked about in the last couple slides, but essentially, and I think Brian touched on this, the UV light reacts with a metal catalyst, and through catalysis, it produces friendly hydroperoxides, superoxides, and hydroxide ions. I know there's a lot of ides and ions there, and then the competing technologies that are also very similar are cold plasma bipolar ion generation and bipolar ionization. And I know Brian's going to have something to say about these.
Yeah. So specifically when we talk about PHI, cold plasma, and then bipolar ionization, they are very similar. The big difference is cold plasma bipolar do not create hydroperoxide, and it's sometimes one of their counter arguments to the PHI. But where they're really missing the boat is hydroperoxide actually exists in the atmosphere, actually at ground level, and constantly reacts. It happens naturally with the sunlight and metals and moisture that's in the air. It's a continuous process, and it's what really helps clean the outdoor air environment, and at least from a airborne pathogen perspective. So go ahead.
Sorry, Brian, and we're going to touch on that in later slides, but essentially the levels of generation that we're producing is far less than that are naturally occurring outdoors.
Right. So the big differences between the three is that PHI has significantly more medical data when it comes to reacting with viruses, germs, molds, bacterias, a lot of third party, and it's a 3 to 4% higher deactivation rate within a space than the other two technologies.
Any questions come in, guys?
Nope, no more at this time.
Okay. So this is kind of what Brian was talking about when it comes to third-party lab data. And in this test, they looked at the H1N1 swine flu. In a controlled environment, the PHI units were installed and turned on, and within 6 hours, the inactivation rate was 99%. And then at that 6-hour mark, with continuously running the PHI, it will remain essentially deactivated.
Right. So I want to add some context to this because One of the questions that we've gotten in the past is, so does that mean that you continually have to take it down from a really high percentage down to a low percentage? And the answer is no. So when you're talking about your normally scheduled occupancy, your units are going to be off at night for energy conservation, of course, and there's no sense in heating and cooling a space that's unoccupied. Because it's already disinfected, your infection rate doesn't really necessarily go up. So as long as you're turning this on prior to building occupancy or right at building occupancy, even with people there, your deactivation rate is going to stay similar to this test. I don't think there's anything else to add to the back of that one.
That's fine. And then in the similar test, they looked at bacteria, mold, and yeast, and although it took slightly longer, they still achieved a 97% inactivation rate at 48 hours. So this has been a slide that speaks to a lot of us.
Hey, Austin.
Yes.
We have a question here.
Okay.
So the question is, were similar testing performed on UV? Oh, that one disappeared on me. On UV light systems, and what were the results? So UV light will definitely deactivate at the same rate as PHI. There's no doubt about that. The real problem is because UV light is harmful specifically to your eyes, it's always installed within the unit where it's not within direct sight or within direct contact of people. So if it's installed in a unit, it's not dangerous, but it only has an effect on the air that crosses over it. So let's say you're providing really clean air to the space, but you have people down there coughing, sneezing, what have you. The UV light has zero effect on that. Now, most of you have probably been in a hospital where you see these little, they look like sconces installed throughout the hallways, which have directional UV, which directs it across the ceiling and not in direct contact with eyes or a person. And it does have some effect in the space. It definitely is better than nothing, but it still doesn't mitigate person-to-person contact, sneezes, or hard surfaces at that point in time. I hope that answered the question.
If not, please add to it and we'll loop back around. So back to this slide. Essentially, this test was developed by the TSA to test the PHI technology as well as the sneeze test. And the reason I find this important is because we know with COVID-19, it's a respiratory infection and it's spread through respiratory droplets, aka sneezing and coughing. Typically, the range of that is 6 feet, and that's why we've been requested by the CDC in the state of Ohio to social distance at the rate of 6 feet, as well as it's recommended to wear a mask so that spray doesn't make it out to other people. In this specific test, they looked at the oxidizers already being in the air, and 99% of the microbes were immediately reduced within 3 feet of the projection. Brian,
yeah, it's significant because it fits into social distancing, but we're all realists here, and we know that social distancing is probably not going to be something that we live with for eternity. So none of our buildings, none of our classrooms, none of our infrastructure is built for maintaining 6 feet reduction. And of course, hopefully this virus is not with us forever. But why this is significant is somebody walking down the hallway sneezes. It can be carried even further than 6 foot, of course, because you have air currents, and as long as it's atomized within the mucus or saliva, it could travel into an office or something else. So the fact that the oxidizers are already there within 3 feet, it's mitigated up to 99%. The ability for a virus or any other airborne pathogen to move throughout the facility, go to a hard surface, and or drift into offices and affect somebody is significantly lessened.
Questions?
No new questions at this time.
Okay, so we touched on this briefly, but hydroperoxides are in the outside air. This is a naturally occurring phenomenon, the UV source being the sun, and there is naturally occurring metals in our atmosphere with these reactions that create hydroperoxides. In addition, H2O2 is produced through the UV source being the sun interacting with water as a natural purification and generation of hydroperoxides. And so let's dive into hydroperoxides. They help reduce pollution and make outdoor air fresh. That's why when you go outside, there are birds chirping, the grass is green, and you can hear the streams running, but it just feels fresh and clean. And we don't have that with the indoor air. The indoor air has no hydroperoxides naturally occurring, and pollutants build up. And so what we're trying to do is recreate some of those natural occurring phenomenon or processes indoors with UVC PHI.
Right, and Austin, I'd like to add to that. So this goes back to specifically some of the governor's recommendations and the CDC's recommendations, and of course ASHRAE's recommendations, and that is to increase outdoor air as far as you can, which does help bring in these natural oxidizers. But the reality is by doing that, sure, it works great on a 70-degree day with no humidity, and it doesn't really add to the load. But when it's really hot and humid or really cold outside, it taxes your systems, and it increases energy significantly. And that goes back to why we call this a part of a green solution, is that you don't have to bring that outdoor air in, which we already know will help mitigate the virus indoors. Now we can create it indoors, minimize the outdoor air, and not have the unintended consequence of high energy bills with bringing that outside air in.
Any questions? I'm going to try to keep this moving because I'm at 28 minutes. I think we're getting close towards the end here. Is there any questions, Brittany or Brian, that you can see?
We do.
Yes.
Okay.
So does this UVC PHI solution disinfect air continuously? And the answer is yes. So it's constantly producing a level of H2O2 and other oxidizers similar to outdoor air. So you're constantly doing the disinfection, and it's 100% of your airflow. So even with outside air, right? Say you're bringing 20% outside air, you're still mixing that with 80%, and you don't have the concentration level that you would have outside. So this is a continuous disinfection, hard surfaces and air. The second question is, does this solution also disinfect hard surfaces? And I guess I kind of answered that before. Yes, it does. It will react with anything, oxidize with anything that is on the surface and or in the air.
And let me add to that, because we've been asked the question, what does that mean we don't need to surface disinfect any longer? And the answer is no. Continue to follow the CDC and the state of Ohio recommendations. Please still surface disinfect, social distance. This is just another tool to add. Essentially we're creating these protective layers. And I've heard Dr. Acton and Governor DeWine talk about these protective layers. So, the more layers that we put into place, the last being maybe if you want to move into some sort of PHI solution, the chance of transmitting the virus has been mitigated substantially. So just real briefly on H2O2, it's one of the most powerful oxidizers we have. It's stronger than chlorine. Through catalysis, H2O2 can be converted to hydroradicals, or OH. That's one of those friendly oxidizers. Those commercialized in the 1800s, introduced into wastewater in the 70s, air applications in the 90s, and is used in nearly every industry.
Right. And one thing, because we get this question often, is, well, is it safe? Is it healthy for people? And the answer is yes. So one of the positive things about hydrogen peroxide specifically is it is 100% metabolized by a human, and when it's metabolized, it's turned into oxygen and water. So it has really, unless it's in an extreme dose, it has zero harmful effects.
Any questions, guys?
Nothing.
Okay. And lastly, or one of the last slides we have here is an installation. So this is a typical UVC PHI installation. This particular example is installed on the air handler. We typically interlock the UVC PHI units and cells with the system's fan. Therefore, it runs in concert with the HVAC system or the mechanical system. And it's installed on the supply side of the ductwork.
Yep, and something really important, and we've had this question too, is how much energy does it use? So at the largest device that they manufacture and that we have installed, which is good for up to, I think, 250 tons, or you're talking in the 100,000 CFM range. It only uses 2.2 amps, so it can be powered from the control circuit, and it's also open voltage, so it can go anywhere from 90 to 277 volts AC, and it doesn't care. So very easy to install, very, very low power, and doesn't affect energy really at all.
Thanks, Brian. So now, if there's any additional questions or any things that we didn't cover that you have questions about as it relates to indoor air quality, please feel free to ask. We'll give it a few seconds, and if we don't get anything, we'll wrap it up. Anything coming in, guys?
Nothing yet.
Okay.
So Austin and Brittany, real quick, are we providing all of the white papers and third-party testing and or medical data that we have for download?
Austin, correct me if I'm wrong, but I believe we can.
Yep.
It can be sent out after the webinar with both the recording and the PowerPoint slide deck.
Yep,
Okay.
we will be sure to do that to everybody who's signed up. Those who attended or those who couldn't make it but are signed up will receive a copy.
All right. So there is a question, and the question is a very good one, and that is, how much does it cost? So we're going to give you a traditional system, right? So an air handler, VAVs, roughly, and please correct me if I'm wrong, Austin, it's basically $75 to $100 a ton in a traditional system. Now, if you start talking about water source heat pumps and or variable refrigerant systems, that pricing kind of changes because we don't install it in every single heat pump, right? Every heat pump is being served by a dedicated outdoor air system. We can install it on a dedicated outdoor air system, which delivers that air with the PHI to every system, and then it works in the spaces alone. So, and then when you start talking about smaller packaged equipment, 5 to 15 ton, Austin, what have you been seeing price wise?
5 to 15 tons is typically like around $2,000 out the door, hardware, installation, everything.
Right, and please note that this is budgetary only for just looking at 50,000 foot capital cost. It can be very specific to each installation depending on how your systems are set up, how much air you're delivering, and so forth. So don't make the mistake of doing a ton per ton pricing on a water source heat pump, because it'll look really big when in fact it's not. So it's really best to get a price.
Yeah, and if you have any questions regarding UVC PHI or anything else as it relates to your HVAC system or indoor air quality, feel free to reach out to us directly and or your representative at the AICUO. We'll get us in touch. If nothing else has jumped in, I thank everybody for coming. Hopefully, we dispelled some myths and some people took away a couple nuggets. I know there's a lot of misinformation out there and a lot of people looking to spend money on filters. And our goal was to provide you with information and tools and resources to inform you that might not be the best investment if you're specifically looking to improve indoor air quality or mitigate COVID-19 specifically.
Hey, Austin, we did get a couple other questions in. One, which I think we may have covered in the last answer, but what are approximate budget costs of UV PHI systems per ton?
Yep.
And
I would start with the $75 number, but we can quickly and easily give some ballpark budgetary figures. I think the question comes up because people don't know if it's $5 or $500,000 per unit, and essentially each one of these units are installed on a specific system. So if you have a split system, that requires a UVC PHI unit. If you have an air handler that serves VVTs or VAVs, we just need to install it on one unit, and that might serve, 50 classrooms. It's just very different for applications.
Right. There's also another question. Sorry, Brittany, I didn't mean to.
Nope, you're okay. Does this affect the amount of fresh air that is required through economizers or fresh air vents?
So the short answer is yes, and it affects it positively. But let me give a little explanation. We kind of talked about this earlier. It allows you to minimize the outdoor air down to whatever the minimum is to meet your minimum exhaust requirements. And but with that, you really need to have a demand CO2 strategy in place. So if you have some CO2 sensors in the space, this doesn't affect CO2. So you will have to, if your CO2 levels go high, have to bring in more outside air, but you can do it on a demand rather than a continuous air turn, which does significantly save on energy costs.
Okay, I think that's all the questions we have for now. So again, thank you, Austin and Brian, for presenting today. Thank you to all of our attendees for joining us. And thank you to the Association of Independent Colleges and Universities of Ohio for hosting us. If you do have any specific questions or want to follow up directly with our team, their contact information is on your screen. You can also contact your local representative as well. Please feel free to reach out to us. We are available and ready to help keep your facilities and occupants safe. With that, we'll go ahead and close it out.
Hey guys, we have one more.
Oh.
And so do we have finance options? There are a number of ways to do financing. Specifically, if you were to do PACE financing, if you were to do any energy financing, this all qualifies for all energy financing. So if it's part of an energy retrofit, it could be tied into it and it actually counts as credits towards that energy save.
Good questions. And I really appreciate all the questions we got today.
Well, again, thanks everybody. Thanks Austin. Thanks Brittany for setting this up. Fantastic job.
Thanks everyone. Have a great rest of your week. Enjoy the weather.
Take care.